In this video, we'll solve a classic Carnot engine example step by step. A Carnot engine has efficiency 0.60, and the cold reservoir temperature is 300 Kelvin. We will find three things. First, the hot reservoir temperature. Second, if the engine produces 300 joules of work per cycle, how much heat is absorbed from the hot reservoir per cycle? And third, how much heat is exhausted to the cold reservoir per cycle? Let's first build a simple energy flow diagram to make this visual. Heat enters from the hot reservoir, labeled T sub H, into the engine. Part of that energy becomes useful work, labeled W out, and the rest is exhausted to the cold reservoir at T sub C equals 300 Kelvin. The efficiency given is 0.60. We'll use two key Carnot relations to solve each part. Part A. For a Carnot engine, efficiency equals 1 minus T sub C over T sub H. We write E equals 1 minus T sub C over T sub H. Now we solve this for T sub H. T sub H equals T sub C divided by 1 minus E. Let's substitute our numbers. T sub H equals 300 over 1 minus 0.60. That denominator is 0.4. So T sub H equals 750 Kelvin. Part B. For any heat engine, efficiency equals work out divided by heat in. That is, E equals W over Q sub H. We write E equals W over QH. Now solve for QH. QH equals W over E. Substitute the numbers. QH equals 300 over 0.60 joules. That gives 500 joules per cycle. Part C. Energy conservation for one cycle says heat in equals work out plus heat to the cold reservoir. That is QH equals W plus QC. We write QH equals W plus QC. Now solve for QC. QC equals QH minus W. Substitute the numbers. QC equals 500 minus 300 joules. That gives 200 joules per cycle to the cold reservoir. We can also check with the Carnot ratio. For a Carnot engine, QC over QH equals TC over TH. That is 200 over 500 equals 300 over 750, which is 0.4 on both sides. So the results are consistent. Summary of results. T sub H equals 750 Kelvin. Q sub H equals 500 joules per cycle. Q sub C equals 200 joules per cycle.